Okay, guys, unit circle. I will make it a plan to, get copied. One, do I not even, oh, I don't even have it in mind. That's why, that's another reason I forgot to copy it. But I will make an effort to get a blank unit circle copied because that is something you'll want to have by your side. And that is something that you'll be able to use on upcoming the end of the chapter test. Okay, I'll talk more about that later. Okay, so 4.3 takes us into the unit circle. We've kind of been prepping with our trig ratios and how we deal with our 3 reference angles of the 30, 45, and 60, how we find those pieces. But now we actually look at the unit circle and all that's involved with it. So let's start with some vocabulary. An angle, okay, in the unit circle has what is called an initial side and it has a terminal side. Now, I will say this initial side is usually at 0. I'm not saying it has to be, but the initial side is the side you start measuring from, which usually is at 0. And when we think 0 on the unit circle, we're thinking 3 o'clock. Is 3 o'clock a good description? You guys handle that, While we're learning, that's kind of my go-to. Now, the terminal side is where the angle ends that we are measuring. Okay, so if you're measuring up to 45 degrees, that 45 degree line is your terminal side. Okay, we have talked on the unit circle. You start at 3 o'clock, and then you go counterclockwise. So an angle that measures positive in the positive direction is an angle that starts here at 0, okay, and it's going to go positive. Okay.
Will they all start at 0?
Yes.
Okay.
I'm trying to think of exceptions, and I'm not coming up with the exceptions.
Okay.
So general rule of thumb is they start at 0. I'm not saying there won't be exceptions, but general rule of thumb, think 0. Now, so positive angle with a measure of alpha counterclockwise, okay? Now, a negative angle, okay? We're going to talk here in this next section that one angle can have multiple names because you can also have negative angles. Negative angles, though, happen by going the other way. So what is backwards in a unit circle is to go clockwise. So if I start at 3 o'clock and head down to 6, I'm measuring in the negative direction. Okay, so this angle right here would be, if I'm going negative and I'm going past the halfway point, so it would be a little bit past negative 180. Whereas this is a positive and it's a little bit past positive 90. Okay, so positive versus negative. Okay, vocab. Coterminal angles. I don't think we use that vocabulary a lot, but we need to know what it means because we use the understanding of it. So coterminal angles are those that start at the same initial side and end on the same terminal side, but they maybe swing around the center more than once. Maybe they go opposite directions to get to that terminal side. So basically they're starting at 0, that's your initial side, and then they end the same place. It's just they might do different things to get there. Okay, so I'll do a drawing here. Examples of coterminal angles. So first of all, 90 degrees. What comes to mind with 90 degrees? If here is my 0, yes. So here's my starting point. Where's 90 going to go? 90. Right? So like if you start at 0 and you go up, you're at 90. That is what 90 degrees looks like. Fair enough? Okay, and specific on this, that's the direction it faces. Now, 450. What do you know about 450? It's big. Okay. More than a full circle? Okay. Go with that thought. More than a full circle. So, now, where do I start? I still start at 0, yes? Now, if I start at 0, Right there I'm at 90, yes. If I keep going, right now I'm about at, if you can see that, 180. Are you following with me? Now I'm about at 270. Where am I at right now? 360. How much farther do I need to go to get to 450?
90.
Another 90. What just happened? Did I end at the same place of the previous angle? Okay. So that when they talk about they simply swing around the center more than once, that's the idea there. Okay, so my original bluish angle here was 90. My red dotted is showing that, okay, as I measure, that's me kind of measuring, 90, 180, 270, 360, 450. Oh, I just landed at the same spot, didn't I? Okay. So coterminal angles, one way to think about them is they are separated by 360 degrees because they're separated by one revolution around the circle. Okay. Now let's try another one here. Negative 270. So where am I starting? Starting at 0, yes. Negative says from 0, I'm going to, instead of going up and around counterclockwise, I'm now going to go down and around clockwise. So now, if I go from here, at this point I'm at, you see, so far I've gone negative 90 degrees. If I keep going, I now have gone negative 180. If I keep going up here, where that just went negative 270, where did it land? That same angle. Okay? So those are examples of coterminal angles. Now, they are all separated by a multiple of 360. 90 plus 360 is 450. 90 minus 360 is negative 270. Okay, so angles can go positive or negative, both ways. But all three of those numbers show this right angle here. Questions there? Okay, now, our brains work naturally in degrees, don't they?
No.
Me included. They work naturally in degrees, okay? However, you cannot totally avoid radians. Do not go into the rest of this unit thinking, I'm just always going to work in degrees. You will get yourself in trouble. You need to work to learn radians with me, okay? There are times where I'll say, okay, let's take this back to degrees. You'll understand it better. But we have to learn to work radians. So, okay. We have three supposed coterminal angles. So first of all, pi. Have you learned what pi is yet? 180, yes. Remember when we convert from degrees to radians or radians to degrees, you're multiplying by pi over 180 or 180 over pi. So 1 pi is equal to 180 degrees. Okay, so if here is my 0, yes. Where's pi? It is what we would normally call 180, correct? So can you agree that this straight line is pi? Also 180 degrees. Okay, so you've got to learn that your circle, halfway around the circle is pi, yes? What's that mean all the way around the circle is? 2 pi. Memorize that. Get that stuck in here. Life will be a lot better, okay? So once around the circle is 360 degrees, or it is 2 pi. So 1 pi is halfway around the circle. Okay. You ready to talk 3 pi? Are you with me here? So we're starting where?
0.
We're starting at 0. 3 pi. So that means I'm going to start going positive. So I'm going up and around to the left. Right here, I'm halfway around, so how far have I gone? I've gone 1 pi. Okay, now we keep going around the circle. How far have I gone right there? 2 pi. So now we keep going more, yes? And now we keep going, and now we are at 3 pi. I don't know, maybe you have a better way to show this, but I'm just trying to give you a visual. Now, let me ask you something. If we kept going in the positive direction, okay? So right now I stopped at technical 3 pi. If I kept going in the positive direction, what's the next time I would hit this same angle? 5 pi? Do you see that? Because every time around the circle, what are you adding? Every time all the way around the circle, you're adding 2 pi. In degrees, every time all the way around the circle, we are adding 360. In radians, we're adding 2 pi. So the next one would be 5 pi. Could we keep going? After 5 pi, if we go around again, we're going to be at 7 pi. Okay, I use that as a lead-in because what's the next one? Negative 99 pi. I don't know about you, but I'm not drawing that one out. But visualize with me. We would start where? We'd start here. And if you start going, negative says we're going down. We're going clockwise. If you start going, where are we at right now? But since we went down, we're at negative 1 pi. Are you with me? If you keep going, you're now at negative 2 pi. Are you seeing where this is going? And now we're at negative 3 pi. If we keep going around, every time you're adding on, or subtracting off, I should say, 2 more pi, right? So if this is negative 3 pi, it's also negative 5 pi, negative 7 pi, negative 9 pi. What do you know about negative 99 pi?
All the way.
It's odd, isn't it? Every odd pi is going to be over here. Every even pi is going to be over at 0. Okay? So yeah, sometimes we can't really count all that out. So we have to use logic. Okay, are you with me? Okay, so there's a side note down here. These angles simply differ by an integer multiple of either 360 degrees or 2 pi radians. And that's because the circle measures 360 degrees or 2 pi radians. I already talked about that, didn't I? Mentioned that several times. But I cannot stress getting this ingrained in your head enough, okay? Okay. Let's look at example 1, which actually has some questions about coterminal angles. Find a positive and a negative angle that are coterminal with the given angle. The idea is not to draw these out, but to do them mathematically. Okay, think about the math behind it. Not that you couldn't draw them out, but they're not always going to be easy to draw out. Okay? So, thoughts on how to find either a positive or negative coterminal angle with 30 degrees? What did we talk about?
Pi over 6.
Well, but I want all degrees answers. They gave me degrees. I want all degrees answers. If we go back to this one up above, 90, 450, and negative 270 were all coterminal names, all for 90.
Oh. Add 360 and then subtract.
Okay? If we take 30 degrees and we add 360, which is once around the circle, yes? What is 30 plus 360? 390. So that's saying if I go all the way around the circle, I'm at 360. If I go 30 more, I'm at 390. Okay? That's a positive coterminal angle. Now, in order to find a negative coterminal angle, we want to subtract 360. So 30 degrees minus 360 degrees is negative 330 degrees.
That's it?
That's it.
Oh my god.
Okay, coterminal angles, the concept is not hard. They are separated by a lap around the circle. If you're in degrees, it's 360 that separates them. If you're in radians, it's not 360. It's whatever that radian amount is.
Ew.
Okay? Okay. Ready for B? Okay. Negative 150. It's already negative, but we still have the same directions. I need a positive coterminal and a negative coterminal angle. So options.
Let's do this.
Okay. We can take negative 150 and we can add 360. And we then get 210 degrees, she says. What else can I do? Okay, I can take negative 150 degrees and subtract 360 degrees. And I get negative 510 degrees. And realize that negative sign in front of 510 is important. Positive 510 is not necessarily coterminal. Okay? Okay, you ready for C? Okay, I go that radian route.
Minus 2 or plus 2 pi to minus 2.
Okay, so we're in radians. We're no longer going to add or subtract 360 degrees.
2 pi.
But what is equivalent to 360 degrees? 2 pi. So that means here, I'm going to do 2 pi over 3 plus 2 pi.
Would it be easier to do 2 pi over 1? Just like.
Yeah. One of the downfalls of radians is you have to be good with fractions. You have to be able to work with fractions. And that's one of the hardest part of radians, I think, is because A, we can't numerically place them, but then they're fractions. Okay? So in order to add 2 pi over 3 and 2 pi, we want to think common denominator. What's a common denominator here?
3.
Common denominator is 3. And then, so 2 pi over 1 becomes
Or 6 pi over
6 pi over 3, yes? Multiplying top and bottom by 3. What is 2 pi over 3 plus 6 pi over 3?
8 pi over 3.
8 pi over 3. Okay, that's one of my answers. How do I find my other coterminal angle? 2 pi over 3 minus 2 pi. What am I going to say to subtract those?
Yeah.
Do the same thing. So we're doing 2 pi over 3 minus 6 pi over 3. 2 pi over 3 minus 6 pi over 3 is negative 4 pi over 3.
This is a lot better than I could.
Okay.
She's like, just like.
Coterminal angles multiple times around the circle. That's all they are. Okay. 360 or 2 pi. Okay. Please do me a favor. Don't just go, oh, that's in radians. I'm going to convert it to degrees and work in degrees.
You can't
I
do that.
need you could, but I need you to learn otherwise. Okay.
That just seems like too much work, anyways.
But some people would say it's easier than learning how to work with radians. But you need to know radians. So.
I feel like radiance is just like simple. Well, I mean, it probably gets harder, but like, just as long as you know how to do fractions.
Okay. Now, so one vocab was coterminal angles. My next vocab is reference angles. Okay? A reference angle is the angle that a given angle makes with the x-axis. So how far is an angle from the x-axis? This angle is always positive and always less than 90 degrees. Or if you're in radians, it's pi over 2 radians. Okay? And that means it's always based off of subtracting to or from 360 degrees. Okay, so coterminal is just another name for the same angle measuring from that initial side. Okay, reference angles are a huge thing. Okay, we use them a lot because our reference angles often take us back to 30, 45, and 60, which are the 3 values in our trig chart over there. Okay, so that's why reference angles are so important. Now, it's based off of how far is it from the x-axis. So, let me draw a picture here. Find the reference angle for each of the following. There's just one right answer. Okay, so this isn't like coterminal where there's multiple answers. There's just one. First of all, your brain has to work to know where 156 degrees is. So, if here is, there's my starting point. Are you with me? There's my initial side of 0. How far does 100, just generally, where's 156? Okay, it's past what and before what? Past 90, before 180. Good enough? Okay, so it's something like that. This is just a picture for our own benefit. Mine's definitely not precise. Now, for a reference angle, I want to know how far that angle is from the x-axis in its closest spot. So where is it closest to the x-axis at? Fair enough? In other words, if I extend this x-axis, it's not closer to 0, is it? It's closer to 180. So when we talk about this reference angle here, we want to know how far is 156 degrees from, in this case, 180, because that's where it's closest. So what's the math I'm going to do? 180 minus 156. And that math gives me the answer of 24 degrees. Okay? Does that meet the criteria of a reference angle? It's positive. It's just the distance from the x-axis. Less than 90 degrees. Okay. Less than 90 degrees. Okay? It's that distance from wherever it's closer to the x-axis. Which means sometimes you're adding or subtracting from 180, sometimes 360. It just depends. Okay. So far, so good. Okay. B. Gonna make you work here. 13 pi over 7. So the tricky part, first of all, is to figure out where is 13 pi over 7.
Almost the full
What'd you say?
almost the full circle, like past 330. 330 is 11 pi over. Wait, yeah, 11 pi over 6.
Okay. So almost the full circle. She's using the reference as past 11 pi over 6. I have a different reference to use, but I see where you're going with that. Almost the full circle. Because 13 over 7 is almost what whole number?
2.
13 over 7 is almost 2, yes? Are you with me? Because when I look at my unit circle, I often reference, is it closer to 1 pi or 2 pi? Well, 13 pi over 7 is almost 2 pi, isn't it?
Yeah.
So when I measure 13 pi over 7, what am I doing? I'm going, right here is 1 pi. What would 1 pi be in terms of sevens? That's 7 over 7, yes? So right now where I temporarily stopped, I'm at 7 pi over 7. If I'm going 13 pi over 7, I'm going to go over here, and I'm going to stop shortly before I get to 2 pi. So right here, this is approximately 13 pi over 7. In reality, I probably should have gone a little bit farther, but okay. So use that reasoning of where is it in relation to 1 pi or 2 pi. 13 pi over 7 is almost 2 pi. Now, so where is this closest to, we need the reference angle. Where is it closest to the x-axis? At 2 pi, yes? So we want to know that distance right there. Which 2 pi, same as 360 degrees. But I don't want to talk 360 degrees because I don't want to talk degrees. But that's where it's closest to the x-axis. So what's the math I need to do here?
Well, 2 pi minus 13 pi.
I want to know how close these are. So 2 pi minus 13 pi over 7. And then you're saying, oh man, again. Okay, how do we subtract?
Your common denominator 7.
Okay.
14 pi over 7.
So 2 is 14 sevenths. So 14 pi over 7 minus 13 pi over 7. 14 sevenths minus 13 sevenths is 1/7 or pi over 7. I don't think you'll ever see me write 1 pi over 7, but that's what we're thinking.
I have a question.
Yes?
So 2 pi, or well, pi over 2 radians is bigger than pi over 7.
Yes. Because half of something is bigger than a seventh of something.
Oh, okay. I was just thinking like the number.
Yeah. Don't, when you're trying to compare them, drop out the pies for a moment.
Think of it as 1 over 7.
Yeah.
Okay.
Okay, so a half of something, if you have half of a candy bar,
It's
is
more
bigger than getting a
7.
seventh of a candy bar. Remember, the bigger the denominator, the smaller the piece size, right? Yeah. This is where, again, we have to go back and get all this fraction details, right? Whether we loved them or hated them. Okay. 580 degrees.
That's a lot of degrees.
It's a lot of degrees, isn't it? It's big.
Very degrees.
Okay. How can I make it smaller so it's easier to work with? What would be equivalent to 580 degrees? I'm not talking reference angle yet.
Are you talking
Okay, if we subtract 360, is it still going to be an equivalent angle?
Is
It is. Okay, it's a coterminal angle. It's still going to have the same location to it. So before you start this problem, I would suggest take 580 minus 360, and we get 220. Does your brain have a little bit better idea of where 220 is? Can your brain work with that one? So anytime you have an angle, whether it be in degrees or radians, that is bigger than 360 or bigger than 2 pi, before you do anything with it, I would subtract off the 360 or the 2 pi. Okay, make it something I can work with. Okay, so there's my initial side. There's my 0. Where does 220 go?
well, it must make 180 and 270.
Okay, past 180 before 270? I mean, we'll talk quadrants here before long. It's quadrant 3 if you want to review your quadrants, but I know we haven't reviewed quadrants in a moment. Although, did that come up in the video yesterday or not? quadrants? No? Oh, okay. I couldn't remember which videos. Okay, so right here, I'm at 180. If I'm going to 220, it's something like that. Okay, so this is 220 degrees, or if you prefer, it is also 580 degrees. Now, what's the question here?
What is the closest?
Yeah. How far is it from the x-axis? So where is it closest to the x-axis? Do you see that? It's closest to, basically if it's on the left side of the graph, it's closest to 180. If it's on the right side of the graph, it's closest to 0 or 360. So right now you need to visualize, oh, this part. And so my reference angle is how far am I from the x-axis, or 180.
Would you do 220 minus 180?
Yeah. In other words, basically always make your math work out to be a positive in this case. So you will add or subtract 180 depending on, you know. So this one is 220 minus 180 degrees, which is 40 degrees. Okay. That's your reference angle. Now, that really leads me into, I think the video was more about what we're getting ready to go into, okay? Or the lesson, I should say. Okay, we're going to talk a little bit, but obviously I'm not going to get very far. We just learned how to do reference angles. And those are going to be important because we're not always going to have, you know, easy numbers to work with. Reference angles give us easy numbers to work with. So we're going to go back and review our 6 trig functions, okay, and how to find the 6 trig functions of theta given an ordered pair. So when you think about the ordered pair 5, 3, what's your brain say to do on 5, 3? Ordered pair. 5, 3 says to go right 5 and up 3. So, in other words, 5 is the x and 3 is the y, yes? Or let's use this picture. From the origin, we're going to go right 5 and up 3. And then we're going to get to this point that is the ordered pair 5, 3. Okay? That's how, when we talk about these points, we're thinking in terms of forming a right triangle. Do you see the right triangle? Yeah. Okay. Obviously it's already drawn here, but any point can form a right triangle. Because we went right 5, up 3, and then we have, it's our hypotenuse, but we also talk about it as the radius. It's the radius of the unit circle we're talking about. Okay? So R does stand for radius. Can you find the length of the radius for me?
Yeah.
How?
I know how to do it. Let me do it.
You could do sine.
We don't know an angle measurement though.
Oh, no, we don't.
Go basics. Go what I didn't want you using the other day.
5 to the second plus 3 squared equals c squared.
What's she using? Pythagorean theorem. Okay, I'm going to put it in terms of instead of ABCs, I'm going to say x squared plus y squared equals r squared. Okay, so if we do that, because we'll need to know r for this problem, 5 squared plus 3 squared equals r squared. What are you getting for r?
32. Yes.
Square root of 34, right? 25 plus 9 is 34, square root of 34.
Yeah.
And I will say, if you want to just learn and use, the shortcut for your radius will always be the square root of x squared plus y squared. If you just want to get in the habit of using that, you can. Okay, we know all of our sides. We're going to use SOHCAHTOA to finish this problem. Because what we're being asked to do, here's theta, yes? We're being asked to find our 6 trig functions, which means we need to find
All 6 of them?
sine, cosine, tangent, and their reciprocals. But this is easy. Do I have all my information? Yeah, and then what do you have to know? You have to know, what's our phrase? SOHCAHTOA. Okay. Hopefully we'll be here tomorrow and we'll pick up on that in person.
Did Miss Rogers ever show you the Indian video? The guys